To solve bonus question 2, I first started with drawing a diagram of the pulley system and the two masses attached to the string. After that, I separated the equations into the left one, so the alpha mass, and then the beta mass for the right side. I then used the tension equations. So if it is going up the plane, which alpha is, then it is it's plus mass times acceleration, as you can see here. And then I've just rearranged this equation for A. Then for the beta, the right side, because it's going down the plane, it is take mass times acceleration, and I have then also rearranged it for A. Once you have these both in terms of A, the A is the constant, and therefore you sub both equations to make them equal each other. Then after that, you rearrange the equations until you get to the final equation, which is T equals m1 m2 times g, in brackets sine alpha plus sine beta, close brackets, all over m1 plus m2. Then for the second part, you know that for the masses to have uniform motion, the A must be equal to 0 acceleration. So you separate both the tension 1 and tension 2 equations again, and you sub 0 in for A, the rearranged equation, and you simplify the equation until you get T equals mass 1 times G times sine beta, and then you also do the same for tension 2, which you end up with T equals mass 2 times gravity times sine beta. Once you get this, since the tension in the string is constant, you sub these equations to equal each other, and you rearrange the equation until you simplify it to get mass 1 over mass 2 equals sine beta over sine alpha. And that is the solution for both part A and part B.